Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schreckberg. Hey, Kirk, good talking to you again.
Hey, Fred, it's good to hear your voice.
Yeah. Now, you were offline there. You were telling me that did you talk to your brother into getting a pinball machine, or you just wanted another project to work on?
I just spread the fever. No, we went out and played a few places, and he's done this before, and we've also talked about it previously, but this time he acted on it and actually purchased a new one in box and had it shipped to his house, which
and you were doing remote customer service.
Yes, I was. He called me several times to say, what are these parts for? And, how do I do this? Yeah, where does this go? And things like that. So thank goodness for our phones having, video audios and do real live, on FaceTime and things like that allows us to do this.
Did you have him open up the play field and then say, don't touch that. Don't touch that.
Yeah.
Get your hand away from there.
He said, how do I turn it on?
Well, they hide the buttons,
Well, it's funny. The absolute traditional place for a switch for all pinball machines, everyone that's ever been manufactured that I know of, has been under the right bottom of the right chassis, right under the right flipper, sort of where the bottom near the legs, and it's a toggle switch underneath. Now, the big manufacturer, Stern, decided to make it easier for them to, I think, get an EMI or a FCC certification on what's called the back box, which has just mostly computing devices, and they actually went and put the switch underneath the lip of the back box on the top, so you have to stretch over the machine, and that was, I don't know, they control 80% of the market, so that's what you get.
This is what you got to do.
You can do what you get to do. You decide you want to change a traditional location of something that's lasted for decades, and you can do it because you have you have
the clout. You can do it.
People don't have any choice. So anyway, you had a question.
I got an email, and let's see, it's a failure rate question was the topic of it, and so they're using failure rate as a metric, and that wasn't really the question. It was, what do we include in calculating a failure rate? And it sounds like from the question is because he asked, is an operational stoppage like a blockage count as a failure for this equipment? And I don't know how many times you've had this discussion with people, is where they go, well, what is a failure? Do we count this and not that, and this, that, and the other thing? And as well as I do, is that most Pareto diagrams are dominated by no fault found, or user error, or some other euphemistic thing saying we're going to ignore that.
Right. A customer induced failure, something like that.
Yeah, they actually had the timidity to turn the thing on, and it didn't. It failed.
Yeah, I mean, right, and intermittents are very hard to to decide, whether you count it. But intermittent, anything where you had to reboot the product, I mean, it was not a hard failure because it was not catastrophic. The unit comes back and functions normally.
Yeah, there's some reboots as you lose data, you lose production time.
Sometimes,
if you had to reboot your car in the middle of the freeway, it'd be life-threatening.
Yeah. Reminds me now, cars start themselves and stop themselves at stoplights, and I go, whoa, why they do this? That's kind of weird.
What do we need a stoplight for?
Yeah. Well, the engine turning off and then turning on when you.
Well, my hybrid did that years ago.
Yeah,
I had one of those.
Weird. But anyway,
I'm enjoying the 50 miles per gallon.
Yeah.
You sit there and idle.
Yeah. Okay. But yeah, there can be several definitions for a failure, and one of them is maybe a processing speed. If you slow down, or you have some condition where it's a microprocessor or a digital system is dropping to a very low functionality, it takes, forever to download something, that could be considered a failure. It's a matter of you defining it up front,
Well, I don't, so I, it's not you, the manufacturer or the designer. It's you need to understand what your customers are going to call a failure.
Right,
That's where I
right,
focus.
yeah,
And that's what I answered
that's
the
right.
question by is like, if you're in a plant, talk to your operations manager. If you got a 5 second downtime where you have to clear a blockage, do they consider that a failure? And
Right.
one plant I was in, they had blockages every 30 seconds. So it adds up to be like 20 minutes of blockage time every day. And like,
Yeah,
that's a
like
lot of, and they're doing bottling at 400 a minute or something like that. And it stops the bottling process.
right. And I worked on, in college, I was down in the basement of the Dr. Pepper headquarters on the canning line, and they do 1,000 cans a minute as it's
Yep.
running through. And there's all kinds of other functions that have to happen besides the cooling and sealing of the can, the cooling of the liquid, carbonation. Then it goes through,
Sterilization step on the outside of the can. And
well, that's a lot of, well, I mean, sterilization, but also to warm up the can, because when they put in the carbonation, it has to be very cold, almost ice cold,
hmm
to hold in the carbonation while the can gets jostled and thing. And then it goes to be so that the cans are not cold when they're put in the cardboard cases, because condensation would cause the
cardboard to
cardboard to
deteriorate.
fail. Right. So they're warmed up through that, and then they're go through an X-ray machine to show that they're filled completely, as
hmm
obviously can't show. So we'd have this little air jet that would, as the cans rush through this measurement device, you'd hear a and it would
The can would get
push.
shoved out.
Yeah, it could shoved out with half empty, partially filled cans, and
hmm
then it would go down the line, and it was a long track. So I guess anywhere along that line, if something had gotten stuck or cans had jammed up, that would have been called a failure.
hmm
But I was on the six-pack ring machine, and you had to. They had three big, huge spools of six packs in long tape
So you had to
form,
change the
and I had to
rolls so they kept
write
going
it
and feed them into the
exactly.
system. And
I had to quickly find the end of one of the continued spools and uh, staple it to the last part of the one going through the machine and make sure it fed through. So any
hmm
point of that, it could fail, and that would be that'd be a failure, but that'd be a user failure if I sometimes I forget to get there in time, because they're running through, and
yeah.
there's three huge spools on a big turn, kind of a big Ferris wheel, and one would be fed, and you had to go load the other. So, yeah, that could be a operator error if I had caused the blind to stop because I hadn't stapled the next tape to the
Yeah.
next
But
set.
but you've been in all kinds of places where they say, all right, well, we're not going to count that. That was a Kirk error. And so we're not going to count that.
Yeah,
The production
yeah,
manager go, no, no,
right,
no, no, no. You shut the
right,
line down. We got, that counts. And
right,
others, the mechanical engineer for the actual machine that lines up the six cans and puts the rings on it
right.
is saying, well, it didn't tear the rings and it actually got the alignment right and everything else.
Hmm.
So that's
Hmm.
not a failure. It's not a big
No,
deal. But
no,
they don't, it's not the machine's fault. And that's what I went back to him and says, well, one, count every failure in some way or fashion. Every
right,
failure has information that you can make improvements on. And you might, on a production line, you might have, 30 alarms going off, but if you can fix one of them, now you only have 29 alarms going off
but you
through the
kind of
day.
know, right? You kind of know that what your cost per minute or what your profit,
hmm
in a line, in a production line, when it shuts down, you can almost make a business case that those costs, anything that causes, like the pallet machine. I remember it breaking. That was way at the end of the line where it would
Yeah.
stack up cases on a pallet. Well, it's breaking or not being able to stack properly caused the whole line to shut down for,
Yeah. Because you
an
can't,
hour.
You
Right,
can't
because you
put
can't.
boxes out there anymore.
Right, you can't have humans load it the way a machine can very quickly.
You didn't have humans that were willing or able to do it. They
No,
couldn't keep
yeah,
up at all.
no, they wouldn't be able to keep up, and then
That would be
shrink
the I Love Lucy and the Chocolate Factory.
shrink wrap it and all that. So, but yeah, that's part of the understanding of the whole process, the whole overview of well, is it easy for the operator to do these things? That's an opportunity for improvement. Can I get it to automatically? Should I make a automatic feeding system so this operator doesn't have to staple them? Of course, this was back in the 1970s, so
Yeah.
they didn't, but it was.
Well, lucky you weren't standing there trying to line up 6 cans and shove the rings on them
Yeah, yeah,
at 500
yeah,
a minute.
yeah, the old way. No, I'm always amazed at what these, people, companies can build for production of that kind of volume and
Oh
speed.
yeah. Yeah. When you're making that many and it's worth spending the millions or tens of millions of dollars for these bottling machines and
Oh yeah,
different stuff because it pays for itself in a day or day or
right.
two. But when they go down, it's a problem. It's sometimes it's
Well, it's
mechanics
costly.
out there. It's
Yeah,
costly. It
it's
adds up.
costly, right? So, those are anything that I guess contributes to that,
Well,
an
that's the
input.
issue is that that's if you count everything, um, but you want to learn about that the machine that puts the rings on. Is this meeting our objectives, and is what's the cost of running this machine and its maintenance costs and so on? Well, then don't count the bottling machine and don't count the pallet machine. Only count failures for that one machine if that's what you're interested in studying. If I'm the
Right,
mechanical engineer, production engineer for that station, yeah, the other things are important overall, yet this is where I work. And so
right,
count that area.
right.
But the idea of that distinguish between operational failures versus production failures or throughput failures, if that's part of the study, if that's what you want to know to run the thing, it's not in general the top line discount everything. And it's same in product reliability. When you get warranty returns, it's, oh, we don't know what it is, so we're not going to count it. I think is one of the worst responses I ever heard. It says, well, you got a whole, you gave me this tour. There's boxes and boxes of returns over there. What's your failure rate? Oh, it's the 1/10 of 1%. Really? You got half your production from last week sitting
Yeah.
out here as failures. How can that be? And they said, well, we don't count ones we haven't looked at yet. And we don't count ones that we don't want to look at, or we don't count ones that we think is customer abuse. And they just kind of ran down this whole long list of things going, oh, we don't count a lot of stuff. Why do you do that? Well, we want to have good failure rates.
Well,
And
yeah,
I about
well,
lost it at that point.
yeah, yeah, don't,
It's a
it's
production
like
error.
you
That's
got it.
not a real failure.
Well, yeah, this is kind of data manipulation, well, it's just not being honest with your management, it's, trying to say, okay, uh, they're looking for things to blame the outside world, not the internal
Yeah.
operations, so like this machine failed, and it was made by such and such, or this,
But it was their fault,
that
or it
is,
was
and that's a failure. That's for sure.
well,
That's
that
going to be
can was
counted.
out of dimension that caused the failure. And
Yeah.
that's not our fault. It's the cannery
Right.
company that makes it. And like,
Right. Right. So,
no.
right. So it's looking at of failure and blame, that's always a difficult, thing to, you
It's
know,
it's something
it's
not to
a,
do
it's,
if you want to actually make any improvements.
I
Yeah,
know.
nobody likes failures, yet if you don't embrace them and deal with it and report it accurately,
Right.
um, it's in the reliability maturity matrix that I've been talking about for decades now, is the very low, the first stage is they have complete denial. This is in their summary is that something along the lines of, why do customers always have to complain? It's the customer's fault, always. And they just ignore every failure as they possibly can. And so their internal metrics are orders of magnitude better than what's actually happening. And they're blind to what's going on. And then some
Right.
companies say, we got a lot of boxes over there. How come our metrics don't cover that? We need to actually figure this out. And they get better and they get better and they get better. And then I had one client that they were, it was making a telecommunication test and measurement type system. And it was a fielded unit. It went off and measured, I think it was measuring a cell tower, some facet of it that I don't understand. And they were doing pretty good, but they recognized that their overall reliability of their fielded systems was plateaued. It was at some percentage and it wasn't getting better. And they were like, what do we do now? Well, it's an interesting project, right? Well, what do you count as a failure?
All right.
And it was stuff that was diagnosed as like a bad solder joint or a bad board or a loose connector or stuff like that. But the loose connector, they discounted because it's like you said earlier, it's like if you reboot it, like your brother's pinball machine, and it started working. And so they didn't count that failure. They said, wait a second. The customer had to call you, get a return authorization, ship it out to you. You paid for shipping, you paid for diagnostic, you found a loose cable, you reconnected it, retested the thing, and then put it back on the shelf or send it back to your customer. He goes, yeah, we do all that. That cost you money. It cost your customer the loss of the functionality of that device in the short term. That's a failure.
Loss in confidence of your quality. Yeah.
Yeah, that is a failure. And they go, oh, no, nothing actually failed. This is the connector came separate. Was that, well, that was, and they started waving their arms and waffling about it.
Yeah.
No, count that. Somebody calls for, I don't know where the on-off switch is. That's a failure. And he said, well, that was in the user's manual. I said, it's still cost you money. It's a failure.
Right. You had to answer the question. Somebody had to call in and ask where.
Yeah, what's your model number?
Right.
This, that,
and that could be it. I mean, it's really not of a hardware failure. It's the fact that the or your
industrial design was non-obvious.
Right, not obvious, and the only reason I knew where the switch was on the pinball machine is because I've been playing for years and I know where things are and I have them myself. So, I was able to help him. But yeah, that would have required, well, he could have found out from the company, but
it takes you an hour to get a hold of half of these people. So it takes the customer time. It's not leading to customer satisfaction.
Right. So it may not be the hardware. It may be the instructions. It may be the industrial design. It may be a lot of things that cause that the customers send back a good piece of hardware thinking, they didn't understand. It doesn't work because they didn't know the function of it or something like that. But
I had one of them that I got called into the production floor and on the docks, and it was a whole pallet of factory packaged printers. And they're packaged like that to go to distributors that then go out to the different retail outlets and stuff. And it wasn't even broken down. And it was returned as, I don't know, it was 150 printers on this pallet as all failures. And I said, wow. Did they not like the shrink wrap on it?
Yeah, exactly. Yeah.
So I dug into it a little bit, and because it would be a big blip on our, monthly failure rate kind of stuff, and I'd have to explain it. And I talked about, this failure was a policy differential between return to stock, which had a 10% stocking fee, or if they claimed there were failures, they got 100% their money back. So there's something wrong in our ordering system and or our policy that is giving us failures when, for all technical reasons, it's not a failure and it's never even attempted to be turned on.
Right. But it's a business. It's an economic.
It's an economic problem, but if it's going to cost us money, it's a failure. And so I'm going to get involved with this. And my boss was like, what are you worried about that for? I says, it's going to cost us, $600,000 to deal with this because we have to unpackage it all according to our own policy and make sure they all work and then sell them at a discount because they're used. And it's still in the factory pack.
Right. Yeah, I wonder what they returned them with an indication of what the failure mode was, when they send back a pallet like that.
Oh, ESD. Yeah,
Yeah,
it's
yes.
ESD.
Yeah.
Something we just can't figure out one way or the other. Like,
Yeah,
yeah,
yeah.
yeah, okay. No, it was the wrong color. It was the
Yeah,
wrong color.
exactly right.
Yeah, yeah.
Lawn color.
Which is a failure. If you create a
So,
product, if you create a product that is the wrong color and they don't buy it, that is
well,
a design failure.
what if they order the palette with the wrong color? Okay, there's two
It's an
different
ordering
colors.
process. It's a
It's an
failure.
ordering process failure,
Yeah,
right?
it's an
It can
ordering
be
failure.
it can be in the system that it doesn't have anything to do with the hardware.
Yeah. No. And that's what I said. The best way I've ever, and it was somebody was telling me about it, is that if it costs us money, it's a failure. And that's
Right.
one way to expand it away from. I have 100 units here, and I found one resistor was bad, so I'm only going to classify one of the 100 of them as a real failure. Now, for the electrical engineer with that component or the assembly line that's assembling them, that might be relevant information for them. Yet for the overall business, those other 99 still cost us money. And so you
Hmm.
can't ignore those. There's other reasons it came back to you, or other
Right.
reasons the line stopped. And it could be training, it could be awareness, it could be familiarity with your system, it could be on and on and on. And those are all still things that cost you money, stops the line, or customer sends it back to you.
Right. And that's the bottom line is the the cost. If you're
Yep.
have you can make a business case for studying it and saying, look, this is costing us this much money for these kinds of problems. We need to investigate further. But that's, again, we've talked about the time companies don't realize the value they have in investigating further and asking the 5 or 10 whys, this
Yep.
was
Yep.
returned. So there's sometimes that's just a cultural thing in the company, and you got to work within that too. So
Yeah. So I like the idea that, and that was my answer back to this person. It was, count everything and then break it down for
right,
different stations or different parts of your operation and so
right,
on. And then focus on a deeper dive and solving the ones that are the big hitters for you, the most important
right.
stuff. And
Pareto everything,
yeah,
Pareto it, and say, okay, this is user errors and why? Well, the instructions weren't clear in the manual. Okay, or
nobody reads the manual. Come on.
yeah, no, yeah. Or the indicator light, the lights were wrong,
Yeah.
something like that. So it's usually worth investigating if it happens, as significant. It's again the 80-20 rule, right?
Yeah. Yeah.
80% of problems are caused by 20% of the, I forget.
Yeah. Yeah. Yeah, no,
So,
causes, the different causes. Yeah, no, I
right.
get it, but I knew you'd like this one but it's fun diving in on, a really juicy electromechanical type failure mechanism and getting all the cool tools out and playing with it. And sometimes it's a policy problem.
Right. Exactly. So, yeah, be aware. Um, yeah, that's some companies, some industries make money off their failures, and they really aren't uh,
Yeah, it's a subject
motivated.
of a whole nother podcast. Yes, yeah,
And there you can't do a whole lot about it. That's a cultural problem that you can't
that's a
do
different
much
problem. It's a
about. You
business
might
model
quit.
problem.
You want to tilt. What's that? Uh, uh, dream the impossible dream, which is to try and.
Yeah. Well, anyway, so that was a question that came in. I thought we'd have fun talking about that one
Sure.
because we both love when stuff fails and what we do about it and get to deal with it. Except the stuff we buy, we just want them to work and
Right.
get a
Yeah.
little frustrated. But
Right.
the
Like,
idea is that is a question that came across, gave some answers to them, and now I got to go back and say, if you want to dive into this, answer this a little bit better and some ideas of what you can do about it, take a look at the podcast or listen to the podcast. That'd be great. But if you are listening to this and have, issues with what you count and don't count, the culture in your organization, or some other question about reliability and related stuff, we'd be more than happy to get you an answer or point you in the right direction or contact somebody, get you in touch with somebody that can help you. or more often than not, is that then we talk about it on the show and hopefully flush out even a deeper, more meaningful answer for you. So if you got something on your mind, let us know. And we're at accendoreliability.com/go/SOR. There's a couple ways to get in touch with it. Kirk and I and the other hosts are all available through LinkedIn and our About pages. So plenty of ways for you to get in touch. If you don't, we'll count that as a failure, of course.
Yeah, we troubleshoot our own podcast. I don't know.
Yeah, sometimes we have to. Yeah.
Well, let us know, folks, what you think of our discussion here, and we appreciate you listening.
Yeah. Thanks, Kirk. We'll talk to you soon.
Okay, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.